The gas constant, also known as the molar, universal, or ideal gas constant, denoted by the symbol R or R, is a physical constant which is featured in many fundamental equations in the physical sciences, such as the ideal gas law and the Nernst equation. It is equivalent to the Boltzmann constant, but expressed in units of energy, meaning the pressure-volume product per temperature increment per mole, rather than energy per temperature increment per particle. The constant is also a combination of the constants from Boyle's law, Charles's law, Avogadro's law, and Gay-Lussac's law. Physically, the gas constant is the constant of proportionality that happens to relate the energy scale in physics to the temperature scale when a mole of particles at the stated temperature is being considered. Thus, the value of the gas constant ultimately derives from historical decisions and accidents in the setting of the energy and temperature scales, plus similar historical setting of the value of the molar scale used for the counting of particles. The last factor is not a consideration in the value of the Boltzmann constant, which does a similar job of equating linear energy and temperature scales. The two digits in parentheses are the uncertainty, standard deviation in the last two digits of the value. The relative uncertainty is 9.1 multiplication 10^7. Some have suggested that it might be appropriate to name this symbol R the Regnault constant in honor of the French chemist Henri Victor Regnault, whose accurate experimental data was used to calculate the early value of the constant. However, the exact reason for the original representation of the constant by the letter R is elusive. Where P is the absolute pressure, SI unit pascals, V is the volume of gas, SI unit cubic meters, N is the amount of gas, SI unit moles, M is the mass, SI unit kilograms contained in V, and T is the thermodynamic temperature, SI unit kelvins. The gas constant is expressed in the same physical units as molar entropy and molar heat capacity.